for today we want to check something related about concentration, and well, this topic is related about chemistry, and it's important to understand this topic because, for example, here, as you see, we have the situation about different ways to express the concentration. Here, for example, we can confuse this topic with density, for example. We know that density is mass over volume, but what is the problem here? Well, the units. Check the units here. For example, when we talk about molarity, we need to use moles. Okay, the volume, well, the volume we can express the liters. You see, in two situations, here and here, we can talk about liters. But when we talk about the matter, we talk about, for example, mass. Here is the density, and here we use different units. Okay, so that's the main difference when we talk about concentration. The units that we need to use. So, for example, here we have moles, okay, also we have moles and we have equivalents, okay. And here, well, depending about what is the unit that we require, for example, we can use the volume or we can use the mass. But here we talk about the solution, okay, liters about the solution, or volume from the solution, or even kilograms from the solution. Okay, so here, for example, when I say solution, remember that we need to consider the solid and the solvent. Okay, here, for example, the moles or the equivalents, we talk about the solid only. Okay, not about the solvent. So that's very, very important to understand. Okay, what are the units? How can we organize this? And also, well, obviously, the formula. But well, that's gonna start now with order. So, at the beginning, we have molarity. Okay. So, what is the molarity? Molarity is the moles divided by the liters. Okay. It's mole divided by the volume, and this one has the units. This is the formula. Molality is the same. We're gonna talk about the moles, but now we're gonna divide it by kilogram. Okay, 1 kilogram. It's important that you understand this. Okay, it's divided by the unit, one. Okay, the result that you're gonna have is according about 1. Okay, 1 liter, 1 kilogram. Here, that was the molality. Normality is, well, molarity times the number of equivalents divided by the volume of the solution. It's the same, 1 liter. And here, when we talk about equivalent, it's depending about the compound. For example, we have an acid, we're going to check the number of protons. If it's the base, we're going to check the number of hydroxides, okay? Or it's a reaction, like a redox reaction, well, we need to check the number of electrons that we transfer. So that's the situation we talk about equivalence. Here, for example, we need to check the first, or we have 3 examples just for solving this. So, okay, so the first problem say, given a solvent with 250 milliliters of water and 2 moles of sodium chloride dissolved in it, calculate the molarity of the solution. So here we need to check, this is not so complicated. Here we have, well, the formula of the molarity is moles divided by 1 liter. Okay, so here, for example, we need to check, or we need to find the moles. In this case, we have is 2 moles. Okay, and well, the volume we have in this is the moles, and the volume is gonna be 250 milliliters. But we need to transform this in liters, so it's gonna be 0.250 liters. Okay, the only thing that we need to do is, well, to apply the formula. It's gonna be 2 divided by 0.250 liters and moles. And here, one situation, you're gonna see what is the answer. The answer, well, is gonna be 8. Okay, 8 moles. Okay, because if you divide 2 divided by 0.250 is gonna be 8. So the result is 8 moles per liter. Okay, it's a situation that I mentioned before. When you see the formula normally you can see this is the molarity is moles divided by 1 liter, but here we are talking more about the answer, okay? The answer or the expression is this, is moles, 8 moles per liter. Here, when we talk about, well, the application of the formula, the only thing that you need to do is transform this in liters, okay? Is the only thing that you need to do. Transform the volume, no matter what is the unit, milliliters, cube meters, or whatever, you need to transform in liters, just to have this. Okay. Next situation. Here we have, imagine that you have 200 grams of sodium chloride dissolved in 500 milliliters of water. Calculate the molality of the solution. So here, molality is the same, moles, but we're gonna change to kilograms, okay? Kilograms from the solution. So here, for example, we have to say this. We have 500 milliliters of water. We know that 500 milliliters is equal to 500 grams, okay? But remember, we need to express in kilograms, so it's gonna be 0.5 kilograms, okay? That's gonna be the unit that we need to put here. And now, well, the molality, we need to check, also one situation here. Here we don't have the moles, okay? We have the grams. So we need to transform this 200 grams in moles, okay? The way that we need to do this is applying the formula about the moles. How can we transform grams in moles? Well, it's gonna be moles equal mass divided by molecular, or well, molecular weight, okay? Molecular weight, and this is gonna be like 200 grams, and well, divided by is 58.5 grams, okay? You can verify this in internet, okay? Or also, well, you need to calculate the molecular weight from sodium chloride. But when you apply this, the result, just let me calculate it here, is 200 divided by 8.5, and it's 3.42. 3.42 moles, okay? Here is grams over mole, the units about the molecular weight. So now that we have the moles, it's going to be simple, okay? Only we need to apply the formula. Moles divided by kilograms. So it's going to be, the molality is going to be 3.42 moles divided by 0.5 kilograms. If you multiply, or what, if you divide it, or multiply times 2, it's going to be the same. We're going to have 6.84 moles. Molality. Molality or molal. Okay, we can omit this, or we can say 6.84 moles divided by kilograms. So here, the next situation, we need to calculate, probably you can imagine, we need to calculate the normality, okay? So suppose you have a solution of sulfuric acid of molarity 2m, calculate the normality of the solution, knowing the sulfuric acid is a divisic acid, okay? So what is this situation? Remember, in normality, well, the formula is going to be molarity times number of equivalents, okay, divided by the volume, okay, or divided by liters. Here, the number of equivalents, well, we're going to take it from the condition of the compound. In this case, we talk about sulfuric acid. Sulfuric acid is an acid, obviously, and we need to take 2 protons, okay? 2 protons, there's going to be 2, okay? The number of equivalents is 2. So, in this case, the only thing that we need to do is well, apply the substitution. But here, for example, if you read again the problem, we didn't have the well, the situation about the volume. We don't know what is the volume, but we can take it from the to molarity. Okay, if we know, then we have 2 molarity is 2 moles for 1 liter. Okay, so in this case, the only thing that we need to do is this: is apply the formula. Molarity is 2 times 2 divided by 1 liter. Okay, this is gonna be 4 normal or 4 equivalent by liter. And that's the answer. Well, I'm gonna stop here. I hope that you understand, and if you have any question, you can put in the comments. So see you.